So functions that behave in this wave-like pattern that we have seen are pretty important to describe different phenomena in science. And we would like to define a function, find a function to describe quantities that behave in these wave-like patterns. So we want to be able to describe circular motion, like the height of somebody going around a circle, or we want to be able to describe waves, like light waves, sound waves. There are a lot of wave-like phenomena that we'd like to describe. And the way we are going to define these functions are, again, in terms of like by tracing the height of a point on a circle. And we're gonna, instead of going with a circle that has radius 15, like we saw before, we are going to use a simpler circle. We're going to take a circle of radius 1 to help us describe these types of functions. And so we're going to take a circle of radius 1 that is centered at the origin, and this circle is called the unit circle. So the unit circle is a circle that is centered at the origin, and it has radius 1, and then it goes around, and we are going to trace a point as it moves around the circle to help us define these functions. But to do that, we need to first learn a little bit more about how to describe points on a circle. So that's what this video is going to be about. So first thing, how do we measure angles? And there are two systems that we can use to describe angles. One is using degrees and one is using radians. So we are going to measure angles in degrees and in radians. And radians is really the more important one when you're doing calculus. So that's where we are moving. But degrees is one that we are probably more familiar with. So let's draw in an angle. So an angle starts always from the positive x-axis. So right here we have an angle, and we are measuring it from the positive x-axis to the line above or below it. And we are going counterclockwise to be positive. So the angle that I have drawn in here, let me call it theta, is some positive number. There are some angles that we know very well, like a right angle would be this one right here. So this angle, let me erase the first one that I labeled. Let's just look at a 90-degree angle, a right angle. And I already said it's 90 degrees. So this angle theta right here is 90 degrees. And for degrees, we use that little circle. We can go beyond 90 degrees. So let's look at the angle that ends over here. It still starts at the x-axis, it goes counterclockwise, and it ends over here. Let me call this angle theta prime. And that angle is about, let's see, it's halfway around the circle, that's 180 degrees, and then another 45 degrees. So that is like 180 degrees plus 45 degrees. That is 225 degrees. So 180 is up to there, and then this is an eighth of a circle, that is 45 degrees. All the way around the circle is 360 degrees. So halfway around the circle is 180 degrees. Let's do one more. What if I use that same angle but I went counterclockwise? We actually can describe those two. Let's call that angle phi. and this angle phi, we like to use Greek letters for angles. So this angle phi is counterclockwise, and since clockwise is a positive direction, counterclockwise is negative. So this is negative, and how far is it? It's 90 degrees plus 45, so that is minus 135 degrees. So minus 90 plus minus 45 is minus 135 degrees. So that's degrees, 360 around one full circle. The second way to describe angles is using radians. And how is a radian defined? Let's go over to the circle over here. So here we have our unit circle. It's a circle of radius 1. So here we have our radius 1. And imagine you pick up this radius. I mean, this radius has a certain distance, right? So imagine we are tracing it with, we are taking a piece of string. And we are measuring how far it is, how long that radius is. And then we are taking that radius, so it's like a string. And then we are wrapping it around the outside of our circle. So I would reach about this far. So I'm taking that string and I'm wrapping it around the outside of the circle so that this is like a length also equal to 1. So our radius was equal to 1. And now we also have this little piece of arc that's also equal to 1. Then the angle that we are creating this way. So if I draw in this line connecting my 2 points, that angle is the angle 1 radian. So this angle has measure 1 radian. And if I kept doing that, if I took my piece of string and I wrapped it around another piece, and then another piece, and another piece, and another piece, and another piece, I would get around a little bit more than 6 times. So it's like 6 times plus a little bit. So halfway around the circle would be a little bit more than 3. And the entire length around the circle, I would need an angle of 6.28 and a little bit radians. So all the way around the circle is 2 pi radians. So note, the angle to go once around the circle is 2 pi radians. At least when we have a circle of radius 1, and this might be familiar from the formula for the circumference of a circle. It's 2 pi r, and so if the radius r is equal to 1, the distance all around is 2 pi, and that is equal to the number of radians in an angle that goes all around the circle. So we said in degrees, going around the circle gets us 360 degrees. And so 360 degrees is equal to 2 pi radians. And radians, I mean the name, it has to do with the radius. It's defined by wrapping the radius around the outside of the circle. So 360 degrees corresponds to 2 pi radians. So 180 degrees corresponds to pi radians. And we can use this correspondence to convert from degrees to radians and vice versa. So to go from degrees to radians, we could take our angle in degrees and multiply by pi over 180, because pi radians corresponds to 180 degrees. Or to go the other way around, we can take our radian measure and take 180, multiply by 180 divided by pi. So you can see that 90 degrees times pi over 180, that is pi over 2 radians. So, and we use rad to abbreviate radians often. And so a 90 degree, a right angle in radians is pi over 2 radians.